7.4 quadratic functions. We're specifically going to spend a little more time on solving different types of quadratics. We've done some before, but we're going to look at some different ways here today and apply those things. Okay, so let's look at our definitions. So our first one, zero of a function. Right, so C is a zero if f of C equals 0. So meaning that if I plug that value into my function, then and we get our 0, then that value is called a 0 of the function. Right? It's not that it equals 0, it just means that when I plug it in, the result equals 0. Right? Quadratic function. All right, so this is a function f of x equals ax squared plus bx plus c. Specifically where a cannot be 0, okay? Because if a is 0, that means we don't have the x squared, and it's no longer a quadratic. And A, B, and C are elements of the real number system. Okay, so those are all going to be real numbers there for those pieces. So as long as those things happen, we do have a quadratic. We've looked at those a little bit before. We did some factoring pieces, factoring trinomials specifically. And so we're going to be continuing on with those here. All right. And then our third one here, we're going to look specifically at ways of solving quadratic functions. Really, I should use the word equations because we're going to solve it's in equation form. Okay, so we're going to have a few different ways here to be able to solve these. The first way we already know, we know how to factor. Okay. Now, the problem with factoring is it doesn't always work. There are things that we cannot factor with real numbers. There's probably a way of doing it, but we're not going to focus on that piece. Okay. And so that doesn't always work. The second way is called complete the square. Okay. Complete the square. Now, this one's a pretty out of the way of solving. We could do it, but we're not going to focus on this one. We're going to skip over it. For those of you that may go on to pre-calculus and you see this in there, you're welcome to come back and see me. Let me know if you need help with anything on those pieces there, but it'll be explained more at that point to see how we can do some graphing is more what we do with those pieces. Okay. The next one is called the principle of square roots. Principle of square roots. And that states if x squared equals k, then x equals plus or minus the square root of k. Because we don't know what else is going on there with this. This is the case where we have to find all square roots. We can take the square root on both sides there, but notice that our result is a plus or minus, either positive or the negative for those. Okay, so we'll use that one. And then our last one is called the quadratic formula. Okay, the quadratic formula. Now, this is based on if ax squared plus bx plus c equals 0. So let's just put that in there. If ax squared plus bx plus c equals 0, then x equals the following. That's a pretty long formula. You are going to have to memorize this. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay. Now you need to write that down. make sure that you have that, because we're going to be using that quite a bit here in this section. And that's going to make our lives easier. Now, the good thing about the quadratic formula is it always works. No matter what our A, B, and C are, it's always going to work. Whereas factoring doesn't always work. And then the principle of square roots is a special circumstance. So we all can always fall back on the quadratic formula. Okay. All right, so let's get into solving using these things and seeing what our problems look like. So we're going to solve here. So our first one, we have x squared minus 25 equals 0. Well, since we do not have a b value, we have an x squared and we have a number, this lets me know that I can use the principle of square roots. Because if I add this 25 to the other side, x squared equals 25. Now I can take the square root on both sides. Okay, so if I do that, that means that x equals plus or minus the square root of 25. Well, we know the square root of 25, so x equals plus or minus 5. And this is an acceptable way to write that. In Pearson, they have in the More menu a plus minus button there for you to use. And so you can utilize that here in these problems. Okay, so we got two answers, positive 5 and negative 5. We plug those in, we would get 0 for both of those. All right, let's do another one like that just so we can see it. Here we have 5x squared plus 10 equals 0. Again, I am missing that x value, b. So I'm going to move that 10 over. We're going to get 5x squared equals negative 10. Divide by 5. So x squared equals negative 2. Well, if we use that principle, that means x equals plus or minus the square root of negative 2. Now we know if we plug that in, that's not a real number. But we don't care about it being real or not. We can still do these with the simplification of the complex rules that we learned in 7.3. So we want to do that. We see that negative can be taken out. And so we have plus or minus square root of 2. Now, if we could simplify that square root of 2, we would, but in this case, we cannot. And so this is our result. Okay? So as we've done before, we need to simplify any radicals all the way as much as we can. All right, x squared minus 8x minus 20 equals 0. All right, so now I've got the trinomial, so I can't use that little trick anymore. I'm just moving over the number. Now this is where quadratic formula is going to come into play. Now, if you can factor it, go ahead and factor it. If you see, hey, I can factor that, I can get that down really easily, no problems, then go for it. But it's not always factorable, so it just may be easier to do quadratic formula from the get-go here and work through it that way. Okay. Now, it is also a good idea. Make sure it's x squared, then x, and then the number. And up here, we're going to say A, B, and C. And we're going to take those signs with them. Okay? So whatever the coefficients are. We don't care about the x anymore. It's all about the coefficients. All right, so x equals negative b. B is a negative 8. So notice I put that in parentheses. Anything that I plug in, I'm going to put in parentheses, as I've always done. Plus or minus the square root of b squared. Again, b was negative 8. Minus 4 times a. There's not a number there. That's a 1 times c. That's negative 20. And then we draw our division bar all the way across. And we divide that by 2 times a, which is 1. Okay. Now, when you're showing your work here, I know that there are a lot of things you can put in your calculator, but do break it down just a little bit I don't mind you putting all the stuff under the square root in and getting a single answer, but go ahead and show the square root and do those pieces. I don't have a calculator, so I'm going to have to do a few more steps to get to where I need. Okay, so x equals negative and negative make a positive. Negative 8 squared is a positive 64. And then negative 4 times 1 times negative 20 is plus 80. 2 times 1 is 2. So we get 8 plus or minus the square root 64 plus 80 is 144 over 2. And then x equals 8 plus or minus, well, the square root of 144 is 12. We can actually do that one on those. So always make sure, can I take that square root? If not, can I break it down for those? Now, since I can take that square root, that allows us to start doing the rest of our problem. We are doing 2 problems at once here. What we are actually doing here is x equals 8 plus 12 over 2. And we're doing x equals 8 minus 12 over 2. We're doing both those things at the same time for those, okay? Well, 8 plus 12, that's 20. 20 divided by 2 is 10. 8 minus 12 is a negative 4. Negative 4 divided by 2 is negative 2. And so our answers there are 10 and negative 2, and the order does not matter on that. Okay, so if you can take those radicals and get rid of them, then you need to finish the problem and work through those things. Okay, now being that I did get whole numbers meant that it probably was factorable, but if we didn't see that, this is how you would do that problem. Right, number 4. X squared plus x plus 2 equals 0. Now again, you can label your pieces up above. I'll go ahead and do it again on this one problem, but after this, I'm not going to. So here's A, here's B, here's C for those. Or you can go to the side to A equals B equals C equals. A bunch of different ways we can show those or not show them. As long as you plug it into your formula correctly, you're fine. So x equals negative B. B is a 1 plus or minus the square root. Again, B squared. So B is a 1 minus 4 times A, which is 1, times C, which is 2. All divided by 2, get my house stop there, times A, which is 1. So making sure I plug in all the things. We just had a lot of 1s here. I think it's okay. Those things happen. All right, so negative times 1 is negative 1, plus or minus. 1 squared is 1. Negative 4 times 1 times 2 is negative 8. And then we get 2 there on the bottom. So x equals negative 1 plus or minus square root 1 minus 8 is a negative 7 over 2. Now I see the negative, so I know I'm taking an I out, putting it right in front of my radical here for those. So x equals negative 1 plus or minus I square root of 7 over 2. Now the 7 there does not break down its prime. There's no square root, so I can't go any further with this problem. Except I do need to look here. The 1i, and the 2, can I reduce those? In this case, I cannot. They're not reducible, but it's all or nothing as well. If I can reduce all 3 of those, I do so. But if not, I'll leave it. And we can write it just like this. Now, if you do things in Pearson, they may separate them into 2 different pieces. You can do that as well, but I want to leave it because it's easier to write one and takes up less space. Okay. All right, number 5. X squared plus 5 equals 8x. All right, so this time it doesn't equal 0. So just like with factoring and everything else, we do want it to equal 0 when we have that x squared. We have to put it in the right order. So let's go ahead and move that over. We get x squared minus 8x plus 5 equals 0. So now that I have it in the right order, we have our A, B, and C. So x equals negative 8 for that B, plus or minus B squared minus 4 times A times C, all divided by 2 times A. Now, don't think that A is always going to be 1. It just happens to be in these examples here today, but it can be different numbers, all right? All right, so we're going to get a positive 8. Negative 8 squared is 64 minus 20 over 2. Okay, so that lets me have 8 plus or minus square root. 64 minus 20 is 44 over 2. I'm going to move this up because I am running out of room there and I'm pretty tall. Okay, so now we need to look at this square root. Can I break down that square root? Perfect squares. Well, we do have 4 times 11 gives me 44, and 4 is a perfect square. Okay, so we're going to take our 8 out. We have x equals 8 plus or minus. When I take 4, take the square root of it, I get 2 square root 11, and still have a 2 on the bottom. Now, this is going to be a case where we do need to look at those pieces outside. 8, the 2, and the 2, I can divide them all by 2. Okay, so if I divide the 8 by 2, I get 4. I divide this 2 by 1, I get 1. If I divide this 2, I get 1. So x equals 4 plus or minus. But we don't put coefficients of 1, so we just write square root of 11. We also don't put denominators of 1, so I don't have to put anything on the bottom since it's a 1. And so that is our final result. So a lot of little details in that problem. Okay, so if you need to go back and watch that again and slow it down, feel free to do so for those pieces. But those are the things we're going to look for. Make sure equals 0. Simplify my radical. Simplify my fractions. Now, again, it's an all 3 or none when you're doing those simplifications. So make sure you're looking for those pieces. Okay, and so that's what you're going to be looking for using the quadratic formula.